cover. So if every edge is incident and a vertex in S, therefore we say that S cover all the edges. Or let's say, given an undirected graph G having a vertex and an edge S, a vertex cover with its selected vertex can cover all the edges incident and in. And that selected vertex is what we're going to call the size of our vertex cover. So basically, it is a graph which has a subset of vertices which covers all the edges. Okay, so later on we're going to give you some examples in order to better understand this what we call vertex-cover problem. But this time, we're going to have some discussions about the theory of the vertex-cover problem.
So this is now the theory of the vertex-cover problem. To dive deeper or better understand this vertex-cover problem, explain in the mathematical discipline of graph theory. A vertex cover, sometimes known cover of a graph, is a subset of vertices which covers every edge. An edge is covered if one fixed endpoint is chosen. In other words, a vertex cover for a graph G is a set of vertices incident to every edge in G. In a vertex cover problem, we have to find what is the minimum size of the vertex cover in G.
Okay, so let's try to take a look at this basic example. We have here an example of an undirected graph which consists of the three vertices, which vertex A, vertex B, and vertex C. Okay, so V stands for vertices. It has the three vertex, which is vertex A, B, and C. Okay, and we also have the three edges, edge 1, 2, and 3. So now, if we consider this vertex, which is the vertex A, these vertex cover this edge and this edge. So we have now V-1. V-1 is the subset of V. So we put here vertex A, since it covers this vertex, this edge, and this edge. Okay, so we still have one edge left that needs to be covered. So it's either I choose this vertex B or vertex C. So what if I choose vertex C? So this vertex covers this edge. So I have to put C vertex C and this V-1 since it covers this edge. Okay, so as you can see in our undirected graph, all edges had been covered. So we have now V-1, which consists of vertex A and C, which is the minimum vertex cover of this graph. So again, if V is a set of vertices for this graph, then V-1 is a subset of V, which is covering all the edges, and therefore, the vertex cover or the minimum vertex cover for this graph is V-1, which has a minimum size of 2.
So this is the continuation of our discussion. So I will discuss to you the greedy algorithm. So we all know that algorithm is a step-by-step process. So in this case, we have greedy algorithm to solve this graph. So the idea behind it, we keep finding a vertex which cover with minimum size. So there are 3 steps. Step 1, find a vertex V with the maximum degree, which means V is the vertices. Step 2, add V to the solution and remove V and all its incident edges from the graph. And step 3, we repeat until all the edges are covered. Our goal here is we want all the edges to be covered with the minimum size of vertices. So as you can see, we have 7 vertices consist of A, B, C, D, E, F, G, and also has 7 edges. So we need to figure out how many degrees in each vertices. So vertex A has 2, vertex B has 3, C has 3, and D has 1, and E has 2, and F has 2, and G has 1. As you can see, vertex B and C has the same degree. Either you choose B and C, but I rather choose vertex C. So it can cover this edge, this edge, this edge. So after we find out the maximum degree, we go to the step 2. We add B to the solution, so we add vertex C to the B-1. And then remove V and all its incident edges from the graph. So we remove this part. So we remove this. So step 3, we repeat until all the edges are covered. So as you can see, vertex B will be now updated. So has 2 left degree or 2 edges left. And then vertex F has 1 degree. So we go back to the step 1. We need to find vertex B in the maximum degree. So vertex A and B and E has the same degree, but I rather choose vertex E. So it can cover this edge. So we put vertex E at V-1. So we remove all its incident edges. So we remove this from this graph. So this time there's 2 edges left. So this vertex B will be updated. So has only 1 degree. So I choose vertex A. So it can cover this edge and this edge. So we put vertex A to the solution and then remove A to this graph. So as you can see, all the edges of this graph had been covered. So this is our minimum vertex cover. It consists of vertex C, E, and A. Has 3 minimum size. So that's how greedy algorithm works. So here are some examples of Vertex-Cover Problem. So example number 1, are the red vertices a vertex cover? No, because edges 5 and 6, 3 to 6, 3 and 7 are not covered by it. Because only this edge being covered by the vertices 1 and 2. So let's take a look for another example. So example number 2. Are the red vertices a vertex cover? No, because edges 3 to 7 are not covered by it. Because only this edge are being covered by the vertices 1, 2, and 6.
To give you another example again, a red vertex is a vertex cover? Yes. Why? Because this edge and this edge are covered by vertex 1. And this edge are covered by vertex 5. And this edge and this edge and this edge are covered by vertex 3. So these are the vertex cover problem.